problems here, getting you all ready for the test next Tuesday and Wednesday. Now, I will leave everything that's up here on the whiteboard, but I would definitely write it down in the spots where it goes and corresponds to, because that way you're not having to look up at the board every time you need help or referencing those pieces of information. It's going to be nice having it on the review sheet so that you're just having it next to it instead of trying to read the whiteboard. Now, problems 1 through 12. Factor the following polynomials. Factor the following quadratics. We want to factor it. And our steps for factoring, when we're not solving, just factoring. 1, we look for greatest common factor. We look to see if there's a number or term that can go into each of the terms, or all 3 of these here. And if the number in front of the variable that is squared, our b squared or x squared, we factor it out too. Do we want to look at 1 or 2? Well, we'll look at 2. So 9r squared minus 36r minus 45. The first thing we're looking for is their greatest common factor. Is there a number that goes into all 3? We know there's not a variable because 45 does not have r. Now 9 is the biggest number for r squared, so we just need to check and make sure is 36 divisible by 9 and is 45 divisible by 9. So the number in common, or the greatest common factor across all 3, is going to be 9. Now when we factor 9 out of 9r squared, we're left with r squared. We factor 9 out of 36, we're left with 4 and r. And when we factor 9 out of 45, we're left with 5. So for most of these here, it's a good option or good choice to try to start with the number in front of r squared, or the variable being squared, see if it is a factor of all 3. If it is, we factor it out. If not, we can look at other factors of 9. So the only other factor of 9 would be 3, and we would see if 3 is a factor, if 9 didn't work. At this point here, we'll move on to step number 2. Step 2 is our 2 sets of parentheses with 3 spaces. That's done. Now we move to step number 3, is finding the sign. If the third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, the signs are opposite. Here, the sign of the third term is negative. As soon as we see the sign of the third term is negative, the signs are opposite. Plus and minus. We don't care about the sign of the middle term. The only time we're worried about the sign of the middle term is if the third term is positive. If the third term is positive, we look at the middle term to see what the signs are going to be. Third term's positive, the signs are the same and match the sign of the middle term. Here, the third term's negative, so one's positive, one's negative. They're opposite. Now that moves us into step number 4, factors of the first and third term. Our first term is r squared. That's the only thing we have. So the only factors of r squared are r and r. If we only have one set of factors, we might as well throw them in. Factors of 5 are 1 and 5. We only have one set, so we just need to plug them in. And the last thing we do after we finish step 4, we found our factors and plugged them in, is just to check the middle term. Because we're not going to check r times r, because r times r is r squared. That is indeed the first term. We're not going to check 1 times negative 5, because that is negative 5. That's where we got the factors of the third term. Our middle term, r times negative 5, is negative 5r. 1 times r is positive 1r plus r. So we have negative 5r plus 5r, or negative 5 plus 1, which would give us negative 4r. That is indeed the middle term that we wanted. So those are our factors there. Yes, sir?
Does it matter which one you put one in negative?
It does matter which one we put as negative, but if you put 9 times r minus 5 times r plus 1, you have those 2 sets of parentheses flipped. That is the exact same answer. Now, if you had r minus 1 and r plus 5, that would not get us the right answer. But I think what you're asking is, can we put it as this here? And yes, those are the same answer. Because multiplication, we can multiply any 2 things or 2 or more things in any order. They are the same. Questions on 1 or 2? Because 1 is almost the exact same. We would just factor 7 out instead of 9. You just need one of those two. One through 6. Any other questions on 1 through 6? One of those that y'all want to look at. 5. 3n squared plus 5n minus 2. Now again, the first thing we're going to look for is a greatest common factor, something that goes into all three terms. So we're looking at 3n squared, 5n, and 2. There's no variable in common with all three. 3, 5, and 2 do not have a common factor. There's nothing that divides into all three. So there is no greatest common factor, which means we move on to step number 2, which is our 2 sets of parentheses with 3 spaces. If the third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, the signs are opposite. The sign of our third term is negative, so the signs are opposite. When that third term is negative, the signs are opposite. We don't even have to look at the middle term. If that third term had been plus 2, we look at the middle term, see that it's plus, so that it would be plus and plus. If the third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, the signs are opposite. Now that we have that, we move on to step 4, finding the factors of the first and third term. So the first term is 3n squared. Well, the only factors of n squared are n and n. The only factors of 3 are 3 and 1. We only have one set of factors for n squared. We only have one set of factors for 3. So we just plug them in. Because that's our only option. That's the only thing we have to choose from. Our factors of 2, 2 and 1, 1 and 2. So all we need to do is stick the 2 and 1 in one of the two spots. Doesn't matter which, because again, our last step is to check. Now when we check this here, again, we're mainly just checking for the middle term, because 3n times n is still 3n squared. 1 times negative 2 is still negative 2. Now here, 3n times negative 2, 3 times negative 2 is going to be negative 6n. 1 times positive n is positive 1n. So we have negative 6n plus n, negative 6 plus 1, negative 5n. Is that the middle term we wanted? Well, no. Yes and no. I really say yes and no, because we wanted it to be 5, yes? Is it 5? Well, yeah, it is 5, but it's negative instead of. So since we got the correct number but wrong sign, what I do is, well, say, I'm going to flip the signs. Because if we get the correct number but wrong sign, flip those signs. Because the other option for this here is that we switch the 3n and n, and we switch the 1 and 2. We switch everything but the signs. I'd rather just switch the signs. It's a lot nicer. Because if we check this again, 3n times positive 2 is now positive 6n. Negative 1 times n is now negative n. 6n minus n, 6 minus 1 would give us positive 5n. That's the number we want and the correct sign, so we have our answer. Questions on this here? We'll go on and look at this 6 here. Last one we'll look at, especially for factoring these trinomials. Negative 3t squared plus 11t minus 6. There is no greatest common factor number-wise. There's not a number that goes into 3, 11, and 6. T squared t, no variable there. But because that first term is negative, what I want to do is I want to take that negative out. What we're doing is factoring negative 1 out. We're pulling that negative out. And all that's going to do is change the sign of every term. It's going to make our 3t squared go from negative to positive. It's going to make the 11t go from positive to negative, and make the negative 6 become positive 6. Because for these steps to work, for these steps for greatest or factoring work, we need that variable, that t squared, that first term, that value of a to be positive. Because if it's positive, it's going to make all the steps work just fine. We're not going to have to find the factors of negative 3t squared. We're just finding the factors of 3t squared. Do we kind of see that there? Yes. Now all the steps work just as they've been doing. We have our two sets of parentheses with three spaces. If the third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, the signs are opposite. Here, the third term is positive. So the signs are the same, and they're going to match the sign of that middle term. Negative and negative. Since the third term was positive, now we do look at that middle term sign to see what they're both going to be. They're both negative. Now that takes us to the factors of the first and third term. First term is 3t squared. Well, only factors of t squared are t and t. Only way we can get there. Factors of 3 are 3 and 1, 1 and 3. We only have one option. So we're going to put 3 in front of one of the t's. We'll put 1 in front of the other. But 1t and just t are the same thing. We don't necessarily have to write the 1. 6, this is the first set of factors where we have more than 1. We have 1 and 6 or 2 and 3. 2 and 3. And again, at this point, plug it in whichever one. Pick one of the spots for 2, one of the spots for 3. It doesn't really matter. It does and doesn't, because at this point, we're going to check. So if it gives us the correct middle term, we're done. 3t times negative 3 is negative 9t. Negative 2 times t is negative 2t. And negative 2t minus 9t, well, I said it backwards, negative 9t minus 2t. Negative 9 minus 2 is negative 11. And especially in the calculator, you can't plug negative 9t minus 2t in either calculator, but we can do negative 9 minus 2. It tells us it's negative 11. Now, we're not looking at this term. We're looking at the one after we factor the negative out. So it gave us negative 11t. The middle term we wanted is indeed negative 11t. So that is the correct set of factors. Does that make sense? Because we don't look back to the original one because it still has the greatest common factor, what we pulled out, still in it. So it's not matching up to it, but the one after we took the greatest common factor out. So negative 3t minus 2 times t minus 3. Questions on this here? I'm going to skip number 7. If you want to go back and look at it, I do have the full review video, the full thing, every single problem worked out already up there. I want to look at number 8. Number 8, 4n squared minus 49. We have two terms being subtracted, so there's a good chance this is going to factor as a difference of perfect squares. Now, the main way it will do that is if 4n squared and 49 are perfect squares, we can write them as something times itself. Now, 49 would be what? 7. 7 times 7 is 49. We can take the square root of 49. It tells us it's 7. Now, we need to see what times itself is 4n squared. 2n. Because our a squared minus b squared will factor to a plus b times a minus b. It's our difference of perfect square formula. Now we rewrite it in the squared form so that we know, and we can say what's a and what is b. 2n is a. And our value b is 7. So it's 2n plus 7 times 2n minus 7. And that's it. We're really just following the formula. A, this is going to be the number going first. What times itself is a. Now, a is not going to be 4n squared. A is the 2n, because 2n squared gives us that 4n squared. A is 2n, b is 7. So we get 2n plus 7 times 2n minus 7. Questions on this here? Uh, 9 or 10? 10. We have a squared minus 25b squared. We have two terms being subtracted that are possibly squares. Yes? Can we rewrite, or is a squared a perfect square? Well, yes, it's what? A times a is a squared. Now we could write it just like we did on the last one, which is really just telling us that a is a. Yes. Now we need to figure out what times itself is 25b squared. Well, 25 would be 5, and b squared is just, well, b. So this is going to factor to a plus 5b times a minus 5b. Because it's matching up with our a plus b times a minus b. So our a term is, in this case, is indeed just a. B is 5b. A plus b times a minus b, so a plus 5b times a minus 5b. Questions?
So to get to like the 5, just square root.
Yeah. Really, yeah, that's what we're doing. We're just square rooting both of those to see what the individual term is. Questions on this here?
So it's the bottom line answer.
Yep. And we could have it flipped. We could have said a minus 5b times a plus 5b. It's the same thing. Yes, sir.
So what if we did imperfect squares?
Most likely there's a greatest common factor between the two. Which one are you looking at?
No, I'm just like a question. We have to be like one that's not.
So if it's in this form and they don't simplify, look for a greatest common factor, a number that will go into both. Most likely that greatest common factor is not a perfect square, because if it is, it'll still work. Questions on this here? All right, we'll move on to the next set, 13 through 16. Which one of these do y'all want to look at? $13? So 13, we can use the pattern we just had. A squared minus b squared is equal to a plus b times a minus b. So we could say this is the same as 64 plus 25 times 64 minus 25. And most likely y'all's first thing to do is to grab the calculator from here and type in 64 plus 25, which is going to give us 89. 64 minus 25 is 39. If you didn't grab the calculator at this point, you would have definitely grabbed it now and said 89 times 39 is 3,471. So what were we calculating? 65 squared minus yeah, 64. That'll make a bit of a difference. Well, 64 squared minus 25 squared, according to the calculator, is 3,471, yes? Oh, wait, did I actually need to do this? No, 441 minus 361. $64,160. 4,000.
So we don't need it.
You can just plug it in, yeah. And especially on the ACT. They give you something like this, simplify the following expression, and there's not a single variable in the expression. Stick it in the calculator, let it do it for you. Yes, we can do it by hand, but the calculator is going to do it way faster than we ever possibly could, especially in problems like this.
Put the square inside the thing to see how.
No, I'd type it in just like it is. 1089 squared minus 961. 1089 squared minus 9. 262,400. Because if we plug a number in for a variable, it gives you an equation and asks you to plug a number in, put parentheses around it. But if it just gives you something like this here, type it in exactly as you see it. I wouldn't change a thing. Questions on 13 through 16. Solve the following equations by any method. Now, for the test, there's 4 types of solving quadratic equations that'll show up. Graphing, factoring, completing the square, not completing the square, quadratic formula, and completing square. Yes, completing square. I was thinking square root method. So they're going to ask you to solve by graphing, factoring, quadratic formula, and completing the square. There are points allotted for doing it by the correct method, and there's points for getting the right answer. If you get stuck on a method for finding the right answer, especially it tells you to solve 17 by factoring, couldn't figure out how to factor it, but you graphed it and got the answer, I will still take those as the correct answer. You will lose the points allotted for solving it by that method, but it's better to get the answer than to get stuck, get nothing by doing it by the right method. Now 17, we'll solve it by factoring. Because when we solve it by factor, we need to be able to rewrite it as 2 sets of parentheses being multiplied together that equal 0. Really, for any method, get it equal to 0 first. Get it equal to 0 first. Get everything on the same side. And number 17, we do have it equal to 0. So now we can factor. So we look for greatest common factor first. We look for a number that's in common with x squared, 3x, and 2. There's not a greatest common factor. So we move on to step 2, our 2 sets of parentheses with 3 spaces. Now we're going to find the sign. If the third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, the signs are opposite. Here the third term is positive, so the signs are the same and match the sign of the middle term, so we have plus and plus. Moves us to step number 4, our factors of the first and third term. First term is x squared. Well, the only factors of x squared are x and x. That's it. Factors of 2. 1 and 2. That's it. We only had 1 set of factors, so we just plugged them in. Now, we're going to check and make sure we do have the correct factors. So we're going to check and make sure we have the correct middle term. Now, when you do this here, make sure to do it to the side. X times 2 is 2x. 1 times x is 1x. Positive 2x plus x. 2x plus x is 3x. Positive 3x. Is that the middle term we wanted? Okay. So that tells us these are indeed the correct factors. We do have it factored, yes? So if the problem started with x plus 1 times x plus 2 and it told you to solve it by factoring, is it already factored? Yeah, it's already in factored form. This is factored form, yes? So if a problem started out this way, that's kind of nice. It's already factored. We just have to go from here. Because the reason we factor to solve by factoring is to get 2 things multiplied together to equal 0. Because if I have 2 or more things multiplied together to equal 0, according to the zero product property, one of them has to be 0. And what that's telling us is that either x plus 1 is 0 or x plus 2 is 0. Because once we get a factor, we just set what's inside the parentheses equal to 0. If there's a variable outside the parentheses, we would set it equal to 0 and then solve. So x plus 1, we just need to get x by itself. First thing we would do is subtract 1. X is now by itself, so x is equal to -1. If we had a number in front of x, we would then divide it to get x by itself. For x plus 2, we would subtract 2, telling us x is equal to -2. That's it. So there's points allotted for getting it in factored form, our parentheses being multiplied together, set equal to 0. Then we solve, set both of those equal to 0 and solve. So this one here we solve by factoring. Questions on this here? We ready for the next one? We'll solve number 18 by graphing. We'll say it asks us to solve it by graphing. Solving by graphing, the first thing we need to do is get the equation equal to 0. It is, yes? We're going to grab the graphing calculator. I would either write them down now or I would go back and write them down later. I would have the steps for graphing written down. Because the first thing we do after get it set equal to 0, we're going to hit the button y equals. I would have the buttons written out because we're going to hit y equals. Now make sure there's nothing in any of the other ones. Because if you have stuff written in y1, y2, y3, y4 going all the way down, like I do here, we want to clear it all out. Because we don't want to graph in anything else. It should be pretty much empty, but if there is stuff in there, clear it out. Clear it out. You just scroll down to it and hit clear. Now what we want to do at this point is type the function in. We don't have to type the equals 0. We just need to type the side that has the variables, the non-zero side. And our equation for this here is x squared minus 9, yes? So our button for x is right next to the alpha button, the green button. So we have x squared minus 9. We just want to type it in. And once we get it typed in, we want to hit graph, because that's what we're doing. We're graphing it. And it gives us this here. And our solutions are the values of x that make the function equal 0. We're looking for the values of x that will make y be 0. Now, if it's kind of hard to see what it is on this here, we can go second graph. Yes, sir. Solving by graphing. Type the equation into the 84 plus, into the graphing calculator. So we click y equals first and then go from there. So I did put these steps up here on the board. If you want to put other steps or kind of what your process of thinking through it, put that there. Because we hit y equals and then typed it in. Yes, sir. So hit y, or hit clear. Y equals. So, yep, there you go. Yep. If it is throwing up errors, let me know. For the most part, I can try to get it fixed. But it is going to be helpful to get to this here. Now, again, when we look at this here, we're looking for what values of x make the y value be 0. And there's two of them. We have one at -3 and we have one at +3. Second graph. So you go up and down. So yeah, you're gonna have to keep coming down. Keep going, keep going, keep going. There's one of them. So we see -3.
So -3 equals 0.
So just x equals -3. 3. And then you keep going, and x equals 3, because the solutions are the values of x that make the y value be 0. So we're only caring about the x values. What values of x make y be 0? Now, x can be 0 as long as y is 0. Because if it's the point 0, 0, that's a solution. If when x is 0, y is -12, that's not a solution. Because, again, we're looking for what values of x make the y value be 0. And that's all we have to do for graphing, especially the ones that ask us to graph. Questions on these two? Questions on any of this so far? I'm trying to remember. Okay. I want to look at 23. 23. If there's any of the others that y'all want to go back and look at, that's fine. We'll try to, if we have time to go back and look at them. But I want to look at 23 specifically. Because there might be one like this that asks you to solve this by factoring. Because when we factor, we're trying to rewrite it as two sets of parentheses being multiplied together, yes? Well, wait a minute. Isn't it already two sets of parentheses being multiplied together? So do I need to do anything to factor it? No, it's already factored for me, isn't it? So this is nice because now I can just apply the zero product property because I do have two things multiplied together that equal 0, yes? So that tells me with this here that either what? 2x minus 7 is 0 or 5x plus 13 is 0. It's already written in multiplied form, so we just have to set the two sets of parentheses. What's in each one equal to 0, yes? These are nice. These should be nice. Because all we got to do is set what's inside the parentheses equal to 0 and solve. We don't even have to factor them if they are already factored. For 2x minus 7, to solve for x, the first thing we would do is add 7. Negative 7 plus 7 is 0. Minus 2x is equal to 7. Since x is not by itself, we will divide both sides by 2, telling us x is equal to 7/2. We can plug it in the calculator, make sure it doesn't simplify. If it doesn't, 7/2 is as simplified as it gets. Now we can do the exact same thing for 5x plus 13. We'd subtract 13 from both sides. And then divide both sides by 5, telling us x is equal to negative 13 fifths. So especially if they give it to us in this form here, take what's inside both sets of parentheses, set them both equal to 0, and solve. These are nice because it already factored it for us. We don't have to do anything beyond that. Questions on this here? We ready for the next one? Solve each of the following equations using the completing the square method. 24 or 25, which one do y'all want to look at? $25. Now, we don't necessarily have to, but it might be helpful for some to get the equation equal to 0 first. Might be helpful to get the equation equal to 0 first, because again, we do definitely need the variables on the same side, not necessarily the constant term, but if it helps, get it equal to 0 first. Step number 1. Is A equal to 1? If not, make it so. What if A is 1? Do we do anything for step 1? No, if A is 1, we just move on to step 2. But here, since A is not 1, we have to divide everything by 5. We divide everything by the number in front of x squared. But since it's not 1, we have to divide everything by 5 because we got to make it so. We got to make it be 1. If it is already 1, we don't have to do anything. If it's already 1, we don't have to do anything. We can just move on to step 2. Step 2 says we get the variables on one side, constant terms on the other. The variables, the terms with a variable on the one side. I'm going to write it in a condensed form, variables on one side, and constant terms on the other. Leave 2 spaces. So to do that here, we would subtract 10 from both sides, because our variable terms are our x squared, our 6x, and that's it. Our constant terms, our number without the variable, is 10. So we move it to the other side. Since it's positive 10, we would subtract 10 from both sides. If it had been negative 10, we would add 10 to both sides. Because our 10 minus 10 is 0. 0 minus 10 is negative 10. So that takes us through steps 1 and 2. Step number 3. Find c, which is equal to b over 2 squared, and plug in. Now, I would definitely do this either off to the side or all the way at the bottom of the page. I'd do it somewhere where we're not going to end up immediately writing over the top of it. So I'm going to place mine over here. If I were you, I'd place it at the bottom, somewhere where our solving steps aren't going to get in the way of it. Now here, x squared plus 6x, what's the value of b? 6. Would it be positive or negative 6? Positive. So we have 6 over 2 squared. 6 divided by 2 is 3, and 3 squared is 9. So our c that we need to make this a perfect square trinomial is 9. We plug it in its 2 spots. 4, factor, and solve. So we need to factor x squared plus 6x plus 9, but that's nice, because we have a set of parentheses squared and we do have x inside there, yes? The number and sign of the term that goes inside that parentheses with x is the number and sign of our number inside the parentheses before we squared it to find c. And that number was what? 3, and it was positive 3, so we say x plus 3. Because when we're finding c, before we square it to find the final value of c, that number inside those parentheses is what's going to go inside here. Since it was positive 3, it's going to be plus 3. Now the other side, we have negative 10 plus 9. That is negative 1. Now the last thing we need to do is to solve. And to do that, we're going to square root both sides. Here, the square root and square will cancel, giving us x plus 3 is equal to plus or minus. Whenever we take the square root of both sides, we have to put the plus or minus. So plus or minus. Now we do need to simplify the square root of negative 1. Well, the square root of negative 1 by definition is I. Anytime we have a negative inside of a radical, you've got to bring that negative out as I. Got to bring that negative out as I. Then whatever's left over inside the parentheses, we can use the 30xs to simplify it from there. But the square root of 1 is just 1, telling us it's 1i, or just I. Now we can say we're done at this point if x is by itself. It is not, so we'll minus 3 from both sides. The number that we add or subtract, we're going to want to put it in front of the plus or minus, telling us that we have negative 3 plus or minus I here. All right. No idea. Questions on how we got to this here? Are negative 3 and I like terms? No. If the number that we take the square root of, either A has I in it because it's negative, or B does not simplify completely, because if we're left with 2 square roots of a number or a square root is still left over, they're not like terms. We can't just add and subtract. If it had become, say, 1, I can do negative 3 plus 1. I can do negative 3 minus 1. We do need to simplify. If we can simplify, we need to simplify. If we can't, don't. Just leave it there, okay? And one of the best things I would suggest, especially in the simplifying part, when we're getting to the end, write out each simplification step as you do it, because there I can at least help give you partial points for simplifying. You're getting it down to the final answer. If you jump straight to it, especially on quadratic formula, and simplify something wrong in one step, I'm not going to see it. So writing more of the simplifying is better for you. Okay? Questions on any of this here? We're going to finish this on Monday.